Hi everyone, my name is Melissa Davis, and this is the first video of Sparks and Circuits. I've named it Circuitry 101 because today we're going to be doing a simple circuit where we light up a light or an LED with a battery. We're going to be doing this all on a breadboard. So, the cool thing about this is that it's actually kind of advanced. I had never seen or used a breadboard until I went to college, and now I'm an electrical engineer, so it's kind of cool that however old you guys are, you're going to be doing something I learned in college and even learned my sophomore year. So this guy's called a breadboard. You'll be wondering why it's called a breadboard. It's not brown, it doesn't taste like bread. This is called a breadboard because back in the 1920s, when all the electrical circuits were beginning to be made, they were mostly radios, and the parts were really, really big. So in order to keep all the parts together, keep them in the right space, they were looking for something that was nearby, and they wanted to keep everything close together. So what they ended up doing is they ended up finding boards that people cut bread on. So you can see this down here. That is a wooden board, like quite literally a bread board that you cut bread on. And they had these big components. These guys are light bulbs. I'm guessing this is a capacitor or a battery. And what they did is they drilled everything into this board, so it was wood. So you can see all those little screws. They drilled everything down and kept it in place. So later on, technology evolved and we have much smaller components. Since we have smaller components, we can use a much smaller board. We can do a lot more on something this tiny. However, we just kept the name breadboard because it's kind of fun. So in order to make all of this, you need a few different things. We're going to need your breadboard. You're going to need a battery. I suggest a 9-volt battery because it's easier to do the connections, but you probably need 5 volts, or if you have AA, you want to put 2 in series to connect them. You need some jumper wires, some LEDs. We're going to go into detail what LED means. We need one of these, and you most definitely need a resistor. So these little guys are actually really important. Resistors are necessary because if we just used an LED and the battery, you would probably break the LED. You grab some paper. Alright, so now we have the dry erase marker, dry erase page back. And when you think of an electrical circuit, one of my favorite analogies is to think about a slide. So we have this normal slide, and what the battery's main job is to give energy and give power to these little materials. They're electrons, so we can just call them cute little circles. And what the battery does is it gives it power to go all the way up those stairs, and then those electrons have all the power with little circles. They go sliding down the slide, and during that sliding down is when you see the light turn on. However, we really need a resistor in there, because if we let these guys go down without any resistance, there's not a slope in there at all, there's no bumps, there's no friction, the slide looks a lot more like this. That looks like a very dangerous slide. Don't you guys think that? So see how fast that goes down and how steep it is? We don't want that. That's very likely going to blow the LED, which is not, it's not going to make any noises or anything, it just stops working. So if we add a resistor in, it makes the slide longer. So then we still have the same battery that scoots all these electrons, little circles to the top, and the resistor is what lengthens this out. It slows them down just enough that we can see the light turn on. There we go. So these guys are really important. It's also kind of cool about them is that you can really see how technology has changed. Where did the light go? You can really see how technology has changed, because the resistors we're going to use today are these little guys, probably about the size of your thumb. They're pretty inexpensive, and they're really lightweight. So we're going to be using these resistors. Back in the 1920s or the 1900s, when they first started making circuits with resistors in them, they were much bigger. They're probably about the size of your hand or your finger. This is my biggest resistor, and it's bigger because it can handle a lot more power. It won't get hot or anything. Imagine this thing being 10 or 50 times bigger. That's how big it was when they first started making resistors. But the really cool thing is that these resistors, the ones you're going to be dealing with today, they're likely going to be blue or tan, and they have these little bands on them. Ignore the bands for now, but later on we could talk about how, maybe in a different video we could talk about those bands tell you how much resistance is, how much you'll slow everything down. But we're going to be dealing with these, and we actually only use these now for prototyping or for learning. So we only use these because they're much easier to deal with. Because in actuality, where'd it go? Okay, I found it. In actuality, the resistors we're going to be using are much more like this. So this is actually the inside of an old cell phone. I do not recommend doing this because there's a lithium-ion battery in there, and those are the little guys that like to blow up if you bend it. So don't do this. But you think about the inside of, come on, zoom in. With the inside of a cell phone or a TV or a computer, they don't have the big components. They have really, really tiny ones. The resistors we use now are about that size, and they can actually be much smaller. So that guy right there, that's also a resistor. They work just as well as the old guys, but they're much, much smaller, so you can put a lot more on one chip and do a lot more stuff with it. Alright, so now we've gone to resistor. We're going to be doing LED next. LEDs are light emitting diodes. And what these guys are, they're my favorite thing to work with, because when you put these guys in a circuit, you immediately know if everything's working because they light up. So, let me grab the notebook. Alright, so an LED is LED. It's a light, so like sunlight or any kind of light emitting. Emitting means to give out, or just to emit, or to give off. Diode. A diode is just a fancy electronics word. Basically this means that these LEDs are kind of one-way streets. If you have it hooked up, it's only going to let electrons flow in one direction. One way to know which direction it's going to let you go is this is what a typical LED looks like. Let me grab one right now. See, it has that curved top and has two wires coming out. These wires are called anode and cathode. They probably could be the other direction, so don't take my word for it. But the longer one is just going to notify which way is what direction is going to let it go. So if you think about a one-way street, you have the street, everything's allowed to drive this way. But if you try to enter and go that way, it's like a big wall. So basically, if you think back to the slide analogy, if you get those electrons, the battery is going to push it all the way up to the top. And if we have this connected in the wrong way, it won't let it go by. It's going to be one big brick wall. However, if you have it connected up correctly, it'll flow right down like it's supposed to. It's one of the most common mistakes is to have the LED connected the wrong way, but it's a very simple one to fix. And if you have it connected incorrectly, as long as you have a resistor in there, you won't be breaking anything. Alright, so now we are going to go start making the circuit. Alright, so now that we're back, we got our handy dandy breadboard. And if you look closely, there's all these different holes. And there's two different ways to label everything. So you've got your numbers right here, A through E. We're going to ignore one side of it. It's a pretty much a mirror image, so we're just going to pretend we only want to deal with this side. You see A through E, and then you see 1 through 30. And basically, what happens is there's little clasps inside each of these little holes. There's metal clasps that when you put something in, it squeezes it and holds on tight. Because in order for stuff to be connected and for electrons to flow through, metal needs to be between all of them. So you see the resistor with metal on, and instead of making a circuit and using fingers to hold it together, and then you want to hold the other one together, we want to make sure these guys touch. What we can use instead is this breadboard, and they have the little hands. And basically, everything that's the same number, so you see 24 all the way up here. Remember, we're going to ignore this part. everything up from 24, from that pin, that hole, that hole, that hole, that hole. Those guys are all connected. So another easy way to do this, let's grab the marker. So you think about it. Here we go. We're just going to pretend we only want to look at that one side. So we see that there's the plus and minus. We're actually going to ignore that guy today. Don't need to worry about that. Then we see these holes. What we want to do is if you connect it to the same number, it will be held together. There'll be the little fingers holding everything together. So if I say you want to put it in the same row, you want to make sure the hands are touching each other. So if you put something, stick something in there, you want something connected to the next one, you need to stick it in the same exact hole and then reach to a new hole. We're going to go slowly when we start to build the circuit, but this is basically what you're going to need. All of these, so if you see this, everything I just circled, those are all together. Then over here, all these are together and they're not connected to this, and it's different from that. Everybody's different, but all those 5 are all connected. Okay, so now we're doing the fun part. We're actually going to build it. You can still kind of see the markers. Now what you're going to do, make sure for the first time you want to make everything the same. So you're going to take your resistor. Remember, this is what the resistor looks like. Yours might be blue. They tend to be kind of bean shaped, and they're pretty tiny, and they're also bendy. So what you want to do is you want to take one end, bend it, take that one thing, bend it, and poke it into number 9. Any one of those number 9s. So then the C of number 9, think about battleship, it's 9C. It can be A, B, C, D, or E, doesn't matter. Then we're going to take the other end of this, bend it again, and we're going to ignore this side. So you can put it over here technically, but I'd rather you guys put it on this side. And we'll reach it into, let's reach it into 18. So poke it in, and you'll feel it hit the back. Push it down, it'll hit the back. Now you can see, it's both the blue lines, it's 18C. 18C. So now we have a resistor in there, which is great, but that's not going to do anything. So we're going to add in our LED next. We'll go with the fun one that is clear, because I have a feeling this guy's going to be not clear. So most of these resistors, when you get them, they're going to have the one long pin and a short pin. What I tend to do is I tend to bend this so that they're the same length, but it kind of has a slant to it. It kind of looks like the slide. What you're going to do is we're going to take the long pin. And if you can't figure out the long pin, it's okay. What's more important is we get one in. So we're going to take the long pin, and it needs a buddy. So if you look back to 18, see how those blue, we have A, B, C, D, and E? For mine, I already have C filled. So this is the long pin, and I am going to poke it into E. The other pin is just floating. See, it's all by itself. The way you know that you did this correctly is if you look closely, are those both in 18? They both are, which is great. So now they have a buddy. Those guys are buddies, they're holding hands. Then we'll take this next one and bend it into 23. Push it down. That should be good. So this is basically all we need to poke in. But we can't connect a light to this, so we're going to use these little jumper wires. These guys all have metal in it, so it kind of connects as helping hands. So we look at this. Alright, 18 has a buddy, so we're good to go. Let's look at 9. Is 9 all by himself? Yep. We are going to connect one of the sides of the wires into 9, and the other one's going to be open, be waiting for the battery. So we take the other wire we need. You already see that 18, there's a buddy there, and we already have a twin. This one is not a twin. We're going to poke it in there. Here we go. So now if we look back at the breadboard, look at 9. There's a twin. One right there, one right there. We look at 18. There's another twin. Got a resistor and the LED. Then we go look at 23. Yep, there's 23. we got the wire and the LED. So this is great. Got it hooked up. Now the fun part. We're going to take we got these two wires. These wires are going to connect to the battery. And on most 9-volt batteries, you can twist it and you'll see a negative and a positive. The positive, think of it as the power. It helps it go up the slide. So you want to keep the positive towards the resistor. And we'll keep the negative towards the LED. So what you need to do is you need to take these wires and make sure you touch metal to metal so everything conducts, and touch it. And there we go. We see the light turn on. Isn't that pretty cool? So what happens is if I don't have it connected, there's no electrons flowing through the circuit. If I have it disconnected, the electrons aren't able to move. So that's pretty cool. There's you got your little circuit. And actually you can go in and add different things. You can add another LED, or you can add a button. And what you'll do is you just keep on doing the buddy rule. Take out one wire, put one of the buddies in 23, and the next one can go in 28. And then everything needs a buddy, and buddy it up. So it worked for me. I'll be honest, it's probably not going to work for most of you the first time, just because electronics is really tricky sometimes. So say you connect it, and you have metal touching metal, metal touching metal. It didn't turn on. It just kind of stinks. The first tip to debug it, I want you guys to take the battery and twist it. Do not turn it upside down. There are no contacts right there. I've had people do that. Very creative, but it's not going to help you at all. So if you flip it around, you have metal touching metal. Okay, that didn't work. Flip it back. And that worked, which is great. However, let's say this is off by 1. Oops, it's hard to do through the TV. Okay, this is off by 1. There's no buddy. That guy's in 23 all by himself, and this guy's in 24 all by himself. We say we go to connect it. It's not going to turn on because there's no circle for everything to flow through. This needs to be in the buddy hole. So there's a buddy. This battery's flipping on me. Connect it, turns back on. So one thing you guys can do is you can literally trace the flow of electrons. The electrons are going to come out of this battery, down here, through an LED, through the resistor, LED back here. If you have any questions, feel free to ask me, but I hope you guys had fun and you're able to get your light to turn on.